more maintenance isn't always better, or the Waddington Effect. Almost every maintenance specialist has encountered a situation of increased failure rates of machines or even entire systems after they were put back into operation following a major overhaul. Such installations are often troubled by minor, and sometimes even serious, faults that have resulted from the maintenance or overhaul work just performed. The causes of these faults can vary widely. For example, machine guards not installed, wires connected incorrectly when connecting the motor, oil not refilled in the gear motor, bolts left loose, a foreign object left inside a tank, and so on. The main factor behind these failures is the human factor. Preventing such breakdowns is particularly challenging because people make mistakes in a random, unpredictable manner. It's hard to know when, by whom, and what kind of mistake will occur. All of these mistakes are known as infant mortality problems and are associated with 2 of the 6 failure patterns defined in RCM, reliability-centered maintenance. The above failure patterns show that the probability of failure is highest when a new system is put into operation or when it is returned to service after an overhaul, but then decreases over time. Too invasive and too frequent maintenance increases the failure rate of systems instead of reducing it. This phenomenon was first observed and documented during World War II. In the maintenance field, it is known as the Waddington Effect. At the time, British scientist, biologist, and geneticist Conrad Hal Waddington was conducting operational research for the RAF. His main task was to advise the British military on more effective ways to combat German submarines. One of his first achievements was determining the optimal color for RAF bombers so that they would be less visible to German submarines. He suggested that white would be the best choice. This allowed the bombers to get 20% closer to a target U-boat before being detected, helping the British forces sink 30% more submarines than had previously been possible. His next achievement was even more significant. He recommended that depth charges dropped by bombers be set to detonate at a depth of 25 feet instead of the traditional setting of 100 feet. Reducing the detonation depth led to a 7-fold increase in U-boat sinkings. However, Waddington's most important success came in July 1943. 2 British squadrons tasked with sinking German U-boats consisted of 40 B-24 Liberator bombers. Waddington observed that at any given time, only about 20 of them were ready for a mission. The reasons for this shockingly low readiness varied. Some were waiting for spare parts. Others were waiting for maintenance personnel or were undergoing scheduled maintenance tasks. This was because the conventional wisdom at the time suggested that more frequent preventive maintenance was beneficial, as it would increase the aircraft's reliability during missions. In other words, frequent preventive maintenance was believed to eliminate unexpected failures during missions. Waddington challenged this conventional paradigm. He and his team collected data on scheduled and unscheduled aircraft maintenance and plotted it on a chart. What they discovered surprised them, as the facts did not support the conventional wisdom. At that time, the bombers underwent routine preventive maintenance every 50 flight hours. Waddington found that the number of unscheduled breakdowns and repairs rose sharply after each scheduled 50-hour service, then steadily declined over time. This trend continued until the next scheduled 50-hour service, after which the number of breakdowns increased again. When Waddington examined the maintenance data chart, he came to the following conclusion.
Scheduled maintenance tends to increase breakdowns, and this can only be because it is doing positive harm by disturbing a relatively satisfactory state of affairs. Secondly, there is no sign that the rate of breakdown is beginning to increase again after the 40 to 50 flying hours, when the aircraft is coming due for its next scheduled preventive maintenance.
The solution to this problem, proposed by Waddington's team and ultimately accepted by the RAF, was to develop an improved maintenance program that increased the interval between scheduled maintenance events, eliminated preventive maintenance tasks that did not deliver clear benefits, improved the work schedules of maintenance personnel, produced better and clearer maintenance guidelines and documentation. After implementing these recommendations, the number of effective flight hours for the British Coastal Command bomber fleet increased by more than 60%. 2 decades later, 2 other scientists, aeronautical engineer Stanley Nowlin and mathematician Howard Heap of United Airlines, rediscovered these same principles in their groundbreaking work on reliability-centered maintenance, which transformed the way maintenance was carried out in commercial aviation, military aviation, and later in the civilian industry. Ironically, Nowlin and Heap were almost certainly unaware of the work carried out by Conrad Waddington and his colleagues, as their research for the RAF had been classified. It remained so until 1973, when Waddington's meticulously kept journal documenting his wartime research activities was finally declassified and published. Want to learn more? Visit rcm2.org.